Hello guys, I'm your simulator here. SpaceX performed the fourth test flight of Starship and Super Heavy on 6th June. But one of the engines shut down almost immediately after takeoff. And I was confused. I was saying that what was happening last time everything was fine during takeoff. But with this launch, Okay. If we cover a summary of whole mission, like how successful was this mission and what were the challenges. First of all, the launch was successful with one engine lost. The hot staging was successful. And booster deceleration happened successfully. Hot staging ring detach was successful. Then the booster was trying to back and boost back was successful. Then the soft landing in the Gulf of Mexico of the booster was successful. And this is a big thing, right? Compared to its predecessors. And the Starship gets an orbit, then it starts rotating successfully in the orbit. And you remember that frustrating time when the camera signals were lost due to atmospheric drag? I thought then after entering under the satellites, we were seeing the entire Starship. Then the re-entry of Starship was successful and thruster didn't jam like its predecessors. And we were amazed to see how despite the damage suffered by Starship during re-entry, and it was still functioning and was successful. And finally, Starship was touching the finish line till the end, and both of booster and Starship were almost touching the success line till the last meter. And the success level of this mission was a step forward among the 4 launches. This was a huge success for Starship, and yeah, you have to understand that Starship is ready to carry payload into orbit from the last 2 missions. And if Elon Musk wants, he can successfully launch Starlink missions. But despite all of the speculation, we are here to talk a little deep about the challenges and difficulties of the missions. Let's get started. Throwing the jettison behind. So what do you mean by hot stage after jettison? Before directly addressing that, let's go back to the flight 2. After flight, SpaceX introduced the concept of hot stage separation for the Starship Super Heavy to increase the efficiency and payload capacity of the spacecraft. In this method, most of the 33 Raptor engines on the Super Heavy booster are turned off, but a few remain firing when the engine on the Starship upper stage are ignited. This avoids the loss of thrust during traditional stage separation, where the lower stage shuts down. First, the hot stage separation involved the Starship firing up its own 6 engine to push itself away from the Super Heavy booster. To make this method safe for the booster, an additional ring system was installed on Starships in the stage to direct the blow of the engine. This method could potentially increase the Starship payload to orbit capacity by 10%. Why did they want to jettison this additional ring section? I think this change to reduce mass of the Super Heavy booster. Booster had a mass of up to 3,500 tons. After lift of the mass reduces as the propellant is used during its re-entry phase, it would barely have the fuel for the boost back and landing. As you know, for the Falcon 9, SpaceX mentioned that only keep the fuel necessary for the same process, and this same principle applies during Super Heavy booster too. But additionally, if they could remove some more mass, that significantly doesn't contribute to the landing process, so that's why we should have to remove that part, and that's why they are jettisoning the hot stage adaptation. By jettisoning, SpaceX aims to minimize the risk of potential difficulties during landing and maximize the chances of success, and we use with improved control over the booster. The HSR ejection will occur shortly after the boost back burn shutdown process, and SpaceX achieved commendable success with the introduction with the hot staging jettison step during its inaugural application. Upcoming flight, the hot staging rig may undergo a redesign characterized by reduced mass, simplified construction, a launch when to optimize head and pressure distribution. Case 2. Elon Musk said after the flight, we did switch to a passive, mostly glass heat shield rather than actively cooled steel, as the latter was heavier, at least according to initial. Once upon, Elon Musk turned from a carbon fiber to stainless steel. For reducing its cost, stainless steel is considered more durable than aluminum, with the ability to withstand heat up to 800 degrees centigrade, and aluminum does melt at 650 degrees centigrade. Elon Musk again tweeted, "Why is Starship made of stainless steel?" This article from 5 years ago explains the reasons. Worth noticing that the ship would have failed on re-entry if made of aluminum, as it can take the heat and everything will still need to be improved further in the next flight to increase the ship's reliability. If the heat shield has problem, Elon Musk shared that this flight demonstrated the incredible vigilance of stainless steel. At temperature, he set the goal. We will further hone our 6x300 alloy to withstand even higher temperature. So when will the change he applied? With heat shield spacex cam from the following prototype specifically. From S30 onwards, removing and changing the heat shield design will be easy and won't take much time anyway. It contrasts stainless steel reinforced, maybe more difficulties, and it will not be possible to change the current prototypes. Everything may be upgrades from upcoming production prototypes. During re-entry process, pinky plasma flashes appear. Once again, it's recreated the dramatic moment we saw in March. After a few minutes, the beam gradually cleared and turned orange, red showing the increasing heat. We can also see in additional to plasma beam, there are also strong friction wave coming from the re-entry speed of up to nearly 20,000 km per hour, and then at around T plus 5723 sparks seem to cram through the joint connecting the flap to the main part of the ship, and then flames appear. You can clearly see the ashes flying from the location while one flap connector appears to the completely separated from the rest. After that, it seemed that piece of ash flew into the camera's position and creating this kind of blurry images. But the flaps continue to cling the ships until the end. Because of the small blurry perspective, we can see possibly flap moving gently, possibly due to the impact of seawater. And it was great, huge success. This is just for today, guys. Hope you would like the video. Subscribe my channel, comment about that. Okay, bye bye.